Hi everyone, today we're looking at question 8 part A of the 1998 4-unit HSC exam. So back then question 8 was the last question, so typically the hardest. Here we're told the numbers P, Q and S are fixed and positive, and we're also told that P is greater than 1, Q is greater than 1, and P is equal to Q on Q minus 1. So the question has 4 subparts, and what I'll do is I'll look at each subpart in a separate video. So for this video, we'll look at part 1, which asks us what positive value of t minimises the expression ft equals s to the power of p on p plus t to the power of q on q minus st. So that's what we'll take a look at now. So what I've done is I've just written up what we're dealing with. So we want to minimise this function. And I think at the end of the day, what we're going to have to do here is almost 2-unit techniques. It's nothing too complicated, I guess. The only difference I'd say between here and say 2-unit is we're being given a lot of letters here, and so we just need to be careful to decipher what are the variables and what are the constants. Here it's a function in t, so it's really t that we're concerned with. And hopefully, as you know, if we want to minimize a function, we're going to find its first derivative, work out where it's 0 to determine the turning points, and then work out whether it's a minimum or maximum turning point. And there's a few ways we could do that, but here I think the most natural way is just to find the second derivative and see if it's positive or negative. So let's work through that now. So step 1 would be to find the first derivative. So f dash t would be, well, let's differentiate this with respect to t. So this whole bit here is just a constant with respect to t, so it just disappears. Here we bring down the exponent, subtract 1, so it'll be qt to the q minus 1, still on q. And then minus s, because this t would lose its exponent. So these q's can cancel, so actually we just end up with a fairly simple first derivative of t to the power of q minus 1 minus s. So naturally the turning point is when the first derivative is equal to 0. So let's do that. Let's set this to 0. So therefore we have t to the q minus 1 minus s equals 0. We can bring the s over, so we'll get t to the q minus 1 equals s. And to isolate the t, we'll just do 1 over these exponents. So t would be equal to s to the 1 over q minus 1. So that's the value of t that gives us a turning point. The question remains, is it a minimum or maximum? I think we can guess it's going to be a minimum because we're being told to minimize. And if there's only one turning point, it's the only option we got. But if we want to get the marks, we have to show the working. So basically, is it a min or a max? That's the outstanding question. We want it to be a min, obviously. So let's find the second derivative. So f double dash t would be, we bring down this exponent, so we'd get q minus 1 t to the q minus 2, and then this s would disappear because we're differentiating with respect to t and it's just a constant again. So now what we want to do is find f double dash at this value of t and see if it's positive, then we're going to have a minimum turning point, and if it's negative, we'd have a maximum turning point. So obviously we want to show that this is going to be positive. So let's find f double dash of s to the 1 on q minus 1. What is that? Well, that's going to be q minus 1 times s to the 1 on q minus 1, all to the power of q minus 2. So I guess I could simplify that a little. We could just say, well, that's q minus 1 times s to the q minus 2 on q minus 1. That's kind of what we're dealing with. Now remember, q is greater than 1. which means q minus 1 is going to be positive. What else do we know? Actually, something, I think in the question we're actually told and s is greater than 0. Let me just double check the question. Yes, we're actually told P, Q, and S are all fixed and positive. So S is positive. So we've got Q minus 1 we know is positive, and S is positive. So we could say something like, since Q is greater than 1 and S is greater than 0, F double dash S of 1 on Q minus 1 will be greater than 0, because we're taking a positive number and multiplying it by a positive number to the power of anything. It's still going to be positive, so two positive numbers multiplied will be positive, and I think that's clear. I think an exam marker would know that you know that if you wrote something like this. So you could say, therefore, the turning point is min. So you could say, therefore, ft, this function, is minimized at t is equal to s on 1 on q minus 1. And again, because s is positive, t is positive, and that's kind of what we wanted. So I think that's all there is to this first part. I think it's just a little bit of scaffolding in this question. They clearly want us to show something that is probably going to pop up and become useful in later parts. So hopefully you followed along with that. So now what I'll do is I'll follow up with another video where I work through part 2. All right, tick boom.